So similar shapes, and occasionally some questions come up that are slightly more difficult at GCSE with these two shapes quite commonly used. So the triangle inside the triangle, because of the parallel lines, then our upper triangle has the same angles inside it as the lower triangle. We've got x and y here. We have x and y there because of the parallel lines, and therefore they both share the same third angle. So we look for corresponding side lengths. We can see that the large triangle is double the triangle on the inside. So if we're trying to find this length here to here, so just mark the points there to there, then 5 plus x is in the larger triangle, and this is going to be double, because that's the factor of enlargement, the length of its corresponding side in the smaller triangle. So 5 times x is going to equal 5 plus x. It's going to equal 2 times 5. So 5 plus x would equal 10. So the whole length here will be 10, because it's going to be double 5. So our x, therefore, must be 5. And in the same way, if we were given this as 6, then the full distance there would be 12. And therefore that distance there would also be 6. Now onto this sort of similar triangle set up here. We have opposite angles that are equal, and then because of the parallel lines, we have z angles. So we have an x there, with alternates with the x there, and the y alternates with the y there. So we have the corresponding sides, the base of the triangle, DE and AC, and we can see that AC is 1.5 times DE. So this triangle then is 1.5 times this triangle. Now because the triangle's sort of been flipped, we've got to be careful that they correspond. We get T and S the right way around. If you look at T, then T has the angle Z at the top and the angle X at the base. So T is going to correspond to B to E. So T will equal 1.5 times 4, which you should realise is 6. And S will equal 1.5 times 5, which will equal 7.5. So there's a couple of classic similar triangle shapes that are often given at GCSE, and that's how to deal with it.